This is part 3 and the final part to Chapter 7, Deformation and Strengthening Mechanisms. We were cut off, well, I cut myself off at the end of part 2, so I'm going to pick up back where that slide was. We were in the middle of looking at the 3 stages of annealing. Recovery is when the atoms have enough energy to diffuse into the dislocations to annihilate the dislocations. Not all of them, but a lot of them. Once we move into recrystallization phase, the cold worked crystals begin to be consumed by new seed crystals until the final process looks like this picture on our right hand side. This is the end of recrystallization, where all those large crystals have been consumed. Those are the strengthening mechanism or dislocations. And all of these new little crystals have been forming with atoms basically migrating from the old crystals to the new crystals until we get a pretty uniform cross-section of tiny crystals, and we have finished our recrystallization once the material's gone. And finally, we have grain growth, where after, we started, this one is after 8 seconds, so we start there again. This one's after 8 seconds. And then those little crystals begin to grow. And so little crystals, the atoms in some of maybe the adjoining ones will join up with another one, and they'll all become aligned and they'll grow up larger and larger. So the longer you hold it at that elevated temperature, the more the grains will be bigger. Okay, so small grains shrink and large grains continue to grow. So these are our 3 stages during heat treatment or annealing. Okay, we want to look at this same plot where we had tensile strength, we called it TS. On the y-axis, we had our 3 different phases: recovery, recrystallization, and grain growth. And we saw that our tensile stress started up high at the beginning, and through the process, we reduce the tensile strength down to perhaps what it was before the cold working. And similarly, the ductility, we start to get a much higher ductility level. We regain our ductility because the cold working caused it to be high strength and very brittle. All right, so this is an indicator, again, down on the very bottom with the same axes. We still have our annealing temperatures and our phases indicated here. But now we have our y-axis having some grain sizes, and we have, the time as well. We have a curve where we show that these crystals will start to grow over here because these are there is no plot pre, this 400 degrees or this recrystallization side, because there are no new grains to grow. So we're not plotting the old grains, we're plotting the new grains, the new recrystallized grains. And you can see from this middle part here, this is my favorite, where you have these cold work grains with all of the dislocations in them. They're long, they're elongated and thinner. With time, you start to create new seed crystals. Some of them grow a little bit, and then at some point, right in here somewhere, you begin to not have the old crystals anymore. And as that occurs, like apparently there's still a little bit of it in here. They're very tiny until you get to this point here. This is where you have all new grains. So this is all new grains. And then we move into the grain growth phase, where each of those grains starts to become larger. not all of them, but some of them become larger, some become smaller. So I want to make sure that you will want to make sure that you understand this plot. This is very important. This plot will be on the FE. It probably will be on the final exam. So these are, understanding what's happening here is important. Cold work versus hot work. Okay, remember, hot working is when you deform above the recrystallization temperature. Cold working was below the it doesn't mean that it's cold, it just means it's not as hot as this. We've talked about how grain size does influence the properties. As we allow those little crystals to grow, if we stopped it early, they would have very small grains. And at that point, we have relatively strong and tough at low temperatures. Okay, so we haven't lost all of our strength yet. When they have large grains, we tend to have that tensile stress will be reduced. We'll have good creep resistance, though, at relatively high temperatures. So these are, maybe some reasons why we as engineers might want to choose whether those heat treatments are held longer or not, and those crystals are allowed to grow or not. Okay, so here we are. I told you we were almost finished. In summary, this is the same page that we had at the beginning of this section, and I wanted to just point out that now you know what these words mean. We've talked about how the dislocations are observed primarily in metals and alloys. The strength is increased because dislocation motion is difficult. That happens when you have smaller crystals or when you have many crystals. The strength of the metal, you can implement these particular strategies. Here's your decreasing grain size again that I just mentioned here. Yeah, there you go. You can also do a solid solution strengthening, a precipitate hardening, where you have to fracture the precipitate in order to move the precipitate along the slip plane. And then cold working can strengthen the material, but it'll also, tensile strength will go up, but your ductility will go down. You can recover some of these properties after you've cold worked it. Cold worked metal that is heat treated may experience recovery, recrystallization, and grain growth. Its properties will be altered. So there you have it. We're at the end of chapter 7. Good job. And go ahead and work on the Wiley Plus homework as well as watching the videos for this chapter in Wiley Plus. Thank you.